and the same thing in the other level. So like you would have, let's say this is VDC, this is 2 VDC, this is 3 VDC, and you have also negative VDC, negative 2 VDC, and negative 3 VDC. So this is called like multi-level inverter. Like it has multiple levels of voltage, right? So you can just like have higher voltage. So this is used in higher voltage applications. Also, using multi-level would cause less harmonics. So you can just like improve the power quality. And what else I wanted to mention about multi-level? But however, like what's the problem with multi-level is that it's very hard to control, relative to two-level, very hard to control. Just like to provide the gating signals, and also like more components. There are actually formulas that you can calculate how many components, how many capacitor, how many inductor you would have like in multi-level inverters. We're not going to discuss that, but we're going to have more components in multi-level inverters and have a complex control, and it's definitely more expensive. And also it's going to be bulkier as well. Like it's bulkier, more expensive, bulkier. But the advantages are these ones. You can use it in higher voltage, less harmonics, improve power quality, lower losses. And also one main advantage I forgot to mention, the main reason you can use it in higher voltage is because then you wouldn't have voltage stress on your equipment, right? So if you want to, for example, like create like let's say like a 300 volt right here, like using two-level inverter, then this is like how much voltage it's gonna fall on your switches, right? Then like you either have to buy like higher voltage switches, which are like very expensive, or you can just like have a multi-level inverter, right? So basically break this voltage among many different layers of switches, right? So then you're basically dividing that voltage among different switches, right? So you have less voltage stress on your equipment. So that's why, and on the load as well. So that's why multi-level inverters are used in the industry when you need like higher voltage, also when you need higher efficiency. So like many standards might not be achievable to get with two-level inverter actually. Like if you want to make your THD smaller than a certain value, it might not be achievable with two-level, but it's achievable with three-level. So that's some practical points here. I'm just gonna see like if I missed any point for this lecture. It seems that I covered everything. What I highly recommend for you guys to do is put a full wave or like a full bridge inverter, like single phase, right? And then just like draw a sinusoidal wave and a carrier, a triangular carrier waveform. And similar to what we did, similar to what I discussed for unipolar and bipolar modulation, try to create those gate signals, and then from those gate signals try to draw the output voltage and see if you can draw that. This is going to be very helpful in understanding how PWM works. If you just like watch the video, it's not going to be that effective. If you just like read the textbook, it's not going to be that effective. One thing that would definitely help you is like do it yourself once or twice. Try to do it like at least for one unipolar and bipolar once, and try to see like how you're basically creating these voltages using PWM. That's it for now. in later video, I'm gonna explain the importance of the amplitude and the frequency of carrier signal and modulating signal. And then we're gonna switch to three-phase inverter, which is gonna be the same circuit but with like one additional leg. So don't panic, it's not that much different. It's the same concepts but a little bit more circuitry, a little bit more elements here. One other thing I wanted to mention is that we can filter out harmonics using filters, using passive filters, L and C, right? But usually capacitors and inductors, as you want to have a higher capacitor or higher inductor, they get very expensive. Okay, so instead of having a high capacitor or high inductor for our filters, we try to use other modulation techniques or like making our inverter multi-level to have less harmonics, or like we have the harmonics at the very higher level. Those higher level harmonics are easier to get filtered out. If you have third order, fifth order, seventh order harmonic, it's gonna be a little bit more challenging. You need to spend more money on your filters. But like, let's say like if you have like a 13th order harmonic or like 15th order harmonic, it means like if you have a sine signal with the 15 times 2 pi f, or like 2 pi times 15 f, then this is going to be easier to filter out compared to lower level harmonics. So that's why we try to make everything possible to reduce the harmonics before we get to the filter level. One other thing I should mention, usually the switches are very expensive and are very sensitive, right? So like usually that's why like we have like a lot of protection in practice. We have a lot of protection for switches as well, because we want to save them from spikes, from like accidental triggering, from like errors in the program, like PWM program. So there going to be a lot of protection, like fuses in the circuit, that we are ignoring them here. Like we are simplifying the circuits here. So that's what I wanted you to know. Okay, thank you so much. I'll see you guys later.